Okay, folks. Yep, settle down. Welcome to the first talk by Tagir Valeev. And if there's one thing that we're known for at JetBrains is dogfooding. So Tagir is going to talk a little bit about how we actually use our own tools at JetBrains. Tagir, take it away.
Thank you, Hadi, and hello everyone. Thank you for coming in this hot day. And I will speak about development processes at JetBrains and more specifically about processes in IntelliJ IDEA department. Well, this is not me. This is Dmitry Zemirov, who originally prepared this talk, but unfortunately he cannot deliver it today, so I'm replacing him, and this is me, and I'll do my best. So we are going to cover many various aspects of development, like what's going on local machine, what's going on CI server, how we are doing code review, how we track issues, and how static analysis helps us. What I want to say is that not all the practices we use in JetBrains are probably suitable for your company and your project, mainly because we are not like mainstream product. We are developing desktop application, which is rather different from what people usually do in programming. So don't accept what I say like action points, and probably it doesn't work for you, but still I hope that you may learn something from this. Let's start from repository. We are using Git. Well, no surprises here. I think anybody uses any version control system other than Git. Wow, I see a few hands, but still, I think Git is the majority. So all our IntelliJ IDEA-based IDEs, including IntelliJ IDEA itself, but also PyCharm, RubyMine, PHP Storm, CLion, Golang, and so on, reside in single mono repository. Also, our Fleet ID resides there, and some non-bundled plugins which you can download from Marketplace, but we build and test them together with all IDs. As you may know, JetBrains exists since the year 2000, and since that year we have first code in our company, but this repository has continuous history only since 2005. Still, it's quite a long period of time, and we had several huge migrations. Before, long ago, it was Perforce repository and Subversion repositories. They were eventually converted to Git, and at some point we had like 6 repositories and worked together with all of them. But I guess 5 or 6 years ago, all of them were merged into single monorepo. And after that, at least 2 projects, namely Golang and Kotlin IntelliJ plugin, were also merged. So this repository becomes even bigger. But still, we are not like single repository company like Google or some other companies, because we have separate projects like UTrack, Toolbox, Space, and so on, and they reside in their own repositories. Speaking of numbers, it's still kind of huge. Git folder weighs like 20 gigabytes, and it contains more than 1 million of commits in master branch only. And in terms of lines of code, we have about 10 millions of lines of code in Java, 4 millions in Kotlin, and some other languages. And this repository is very active. We have many development going there. At any given working days, there are like 400 active developers which do something there. And we have more than 200 commits daily in master branch today. So it's pretty active. To manage it, we are using our own product, called Space, which is software development platform. It's somehow similar to GitHub, but you can have it on premise right inside your organization, and it includes a lot of features like Git hosting, code review, CI/CD pipelines, its own package repository like Artifactory or Nexus, and nice IDE plugin, so you can do something right from your IDE, and also issue tracker, chats like Slack, and many other stuff. We don't use all of this right inside IntelliJ project, but still use many things. So our Git repository is hosted in Space, and thanks to scalable distributed architecture, it behaves pretty well. And it's not just big repository, it also heavily used repository, because we have about 10 fetch requests every second. Mainly they are originated from build agents from our CI server, because we have like more than 1,000 of build agents that work simultaneously, and all of them want to have up-to-date source code, so they fetch something from Space. And it also has automated repo maintenance, like garbage collection and so on, so we don't need to care about this. And important thing is that we have some open source parts, for example, IntelliJ Community Edition, which is mirrored to GitHub, but our internal repository is like single point of truth. So, for example, if you submit a pull request to our community IntelliJ IDEA, it will be first merged to internal repository, and then thanks to the synchronization, it will appear on GitHub. And we are doing this using our internal tool, which synchronizes like every 15 minutes or so. So this is how commit tree looks inside Space web interface. Nothing really surprising here. You can see users, commit messages, commit tree, some links to code review and merge requests, and so on. As you can see, the leftmost branch is a master branch. Sometimes some feature branches or something forks out of it, but they are never merged, because we prefer linear history. So if you need changes in master, we rebase them. And here I will speak a little bit more about Git repository branches. We are using master branch for ongoing development, and this is somehow different from many companies, because some companies prefer doing everything in separate pull requests, but we just commit to master, and it allows us to maintain fast pace of development. We have linear history, no merge commits. Even if somebody has a feature branch, we rebase it. But we assume that our nightly builds are stable enough for internal use. And actually, many people in JetBrains use nightly builds of IntelliJ IDEA for their daily work. So they don't use like the latest stable release, but download what was built last night, or the most fearless people just download sources, build sources on their machine, and use this as a main tool. So we have normally 3 releases every year, and they named like year dot number. For example, in this year, 2023.1 was released, 2023.2 will be released like in 1 month or so, and 2022.3 will be released late autumn or probably early winter. So for every huge major release, we have stable branch, and it's created roughly 6 weeks before the release, and naming is like 2 digits from years and 1 digit the release number within the year. So we have 231 after 223. We already get used to this. And those branches are much more stable. Continuous development is going still in master. We already have branch 232 for the upcoming release. But if I commit something today, it will go to the next release 23.3. So, and if I want to put it to the upcoming release, I should perform some additional steps. I will speak about this. And weekly, we have release branches, which are even more stable. They have additional build number there. And actually, all public releases like EIP releases, major releases, and bug fix updates are built from those release branches. So if you need to put something into that branch to fix something there, you should have really big reason to do this. As I said, we use feature branches only limitedly. Some people still use them. It's not prohibited, but it's not encouraged, because when you integrate like every day, much more people test your changes. Everybody who uses nightly builds will find bugs in your new functionality and will report it back much before external users will see it. Even if some feature takes like several months to develop, we prefer using feature flags, or some like internal knobs where we can turn feature off for users by default, but it can be turned on internally by QA engineers and so on. Let's speak a little bit about local development environment. So imagine that you are new employee in JetBrains and you want to install everything you need for work on your fresh laptop. In fact, you don't need to do many things. The main thing is to install a Toolbox app. Anybody uses Toolbox app? Yes, some people definitely use it. It's like a launch pad for all our IDEs. So it's separate application available for people, and you can download it from JetBrains site. It says install Git, but you can even skip this step, because in most of the cases, IntelliJ can do this automatically. Then you log in into Toolbox Enterprise. It's like a service for Toolbox users inside the company. I will speak a little bit later about this. And after that, you can just click in Toolbox interface to install IntelliJ IDEA on your machine. It will install it, then you open, and you can easily clone the project. Just say project from version control, paste the URL, and it will download everything, and it will download JDK, it will download dependencies. If you don't have Git, it will download Git. So you don't need to install anything manually. It will just work. After that, you can compile, debug, whatever, implement new feature. So it's quite easy. Toolbox Enterprise is our relatively new product, which is aimed to help managing our IDEs within big companies, and we are using it internally as well. So it has some convenient features. For example, if your company has some internal plugin and you want that all your developers need to use this plugin, you don't need to go to everybody and ask them to install it. You can just set it in administration interface, and it will be installed automatically to all machines. Or you can set some setting, and there is also some telemetry. So administration of your company may see that if you spend a lot of time on indexing or spend a lot of time on compilation in average, and probably there is something to fix. Such problems can be visible thanks to Toolbox Enterprise. If you like to try, you can find more on the web. Speaking about project setup, we have single IntelliJ IDEA project for entire monorepo, and it contains more than 2,000 of modules. To build all of this, we use an internal build system called JPS. It's just built-in build system in IntelliJ IDEA. So it's kind of unusual choice because most of Java projects you may know using Maven or Gradle. Some probably use Bazel, or some may use SBT, but JPS you probably never heard of. But it works in our case, and it provides additional features. I will speak about it. And what's more important, if something doesn't work, we can fix it by ourselves. We don't need to like submit issue to Maven and wait till they fix it. But we have external dependencies, and they are referenced by Maven coordinates. They can be downloaded automatically from Maven Central, or if we have non-public dependency, it can be downloaded from Space repository. Space also can host binary dependencies. So, and we have a lot of shared run configuration, which are just available in the Git. So if you just clone the project, you have a lot of options. What are you going to run? Here is how project structure looks like. You can see there is a lot of modules, and some of them are actually folders that contain even more modules inside. And there are dependencies. You can configure everything using UI, but they are stored in XML files, which are quite readable and quite writable. So if you like need to perform mass change, like rename some modules using some template, you can just do it in XML files directly. And we are using our custom Java build called JetBrains Runtime. It's currently it's patched version of OpenJDK based on OpenJDK 17. We are in process of evaluating how to migrate to OpenJDK 21, but we have some useful patches there. Here is a view of run configurations. There are also a huge number of them, and you can, like, if you are developing Golang, for example, our IDE for Go language, you can just run Golang, and it will compile only subset of modules relevant to Golang. It will not compile, for example, PHP support if you don't need it. And there are even some very custom things, like we have experimental Kotlin K2 implementation. Today, Svetlana Isakova will tell us more about this. And if you want to use this experimental implementation with IntelliJ community, you can easily do this. So a few words about shared indexes. If you use IntelliJ IDEA together with very big project, you usually have problems with indexing. Indexes are very useful. They allow you to search very fast to find like inheritors or build call hierarchy or many other useful things. But building indexes takes time. And we are trying to solve this problem. First, we have public infrastructure for indexes of JDK and also many popular libraries from Maven Central. And this can be used by you as well. So instead of indexing everything on your machine, you can download indexes from our public infrastructure. But internally, we are going even further, and our CI server, Team City, builds indexes for the whole code in monorepo. It takes about 40 minutes, but you don't need to worry because it happens in cloud when you are sleeping, and when you go and check out everything, you can just download this indexing artifact, and it will take much less time, and your laptop will not be very hot. We are not stopping here. We are working even further to make it even better. So if you are using IntelliJ IDEA with Java projects, you can check whether shared indexes are enabled for you, and you can check whether they improve your experience. It's possible to build the whole mono repo on your machine, and it's pretty fast. If you have like M1 MacBook, it will take no more than 20 minutes, but usually you don't need to rebuild everything. It says that you need at most few times a week, but it's actually an overstatement. Only if like very core dependency changes and everything depends of it, and you need to recompile almost every module, then you need to rebuild, or if some corruption during build happens, but it happens rarely. And incremental build, if you just change something and want to rerun, it may take 5 to 10 seconds. Or if you update from Git and have like several hundreds of new commits, it may take probably a minute or two, but not more. And as you may know, Java allows you hot swapping. So if you compile and run IntelliJ IDEA from IntelliJ IDEA and debug it and find some problem and fix that problem, you don't need usually to relaunch it. You can just recompile, change it file, and it will automatically hot swap the classes. And we are using the technology called dynamic code evolution virtual machine in our own patched JDK, and it allows even better hot swap. For example, it allows adding new methods. Still, we are trying to improve build times, even those 20 minutes, and there is an approach called JPS caches. Like our TeamCity, our CI server, naturally has everything compiled at any given time. So why not? It can share compiled data with us, and we can simply download ready class files and incremental compilation caches. And even if your local version differs a little bit from the version compiled by TeamCity, then incremental compilation caches can you tell exactly what you need to recompile locally to have a completely up-to-date compiled code. So actually every build is an incremental build, and if JPS caches are turned on, you can check out on the fresh machine, and you don't even need to compile everything. Currently, it's internal feature, not available to external users, but if it works great, we may probably make it as a product. And we have some internal tools to monitor how development actually works. For example, there is this page which shows which versions of IntelliJ IDEA our internal developers use at any given day. And you can see that some of them use stable version 2.3.1, but much more are using non-stable versions 2.3.2 dot something, different builds. Some updated yesterday, some updated like a week ago, but still many users using nightly builds. There are many other statistics. For example, those charts show how much time people spend on compilation during a working day. It's aggregate, not single compilation, but total time spent on compilation. And you can see it's usually less than 15 minutes. Let's speak about what's going on our TeamCity. It has thousands of build configurations, and they are configured using Kotlin DSL. So we are using configuration as a code, and it's really convenient approach to configure such huge amount of builds because you can easily reuse code, you can like extract methods, you can perform any usual refactorings. It's just simple Kotlin code, so no problems to do anything you are doing normally during programming. And at any given moment of time, we have more than 1,000 of agents for IntelliJ IDEA related builds. Mostly they are running in Amazon Cloud. We have also some hardware agents primarily for performance testing. Our tests are mostly functional. They are not like unit tests, so we don't test individual methods or individual classes, but we test some observable behavior. So usual scenario is like, let's create Java project using Java 11, then add a single class like this, then place the caret in some position and invoke code completion, and you should see options like this, and that. So test looks like this, and if you see something different, then test fails. Thanks to this, many tests survive huge refactorings when we change everything inside completely, because observable behavior still stays the same, and we have useful tests that were written like 20 years ago or even older. We're also using different testing frameworks just for historical reasons, but tests written on JUnit 3 still work nicely, no need to migrate. If you want to push something to our master branch, you should first run aggregator build, and it includes most of our tests. Currently, it's about 300 of thousands tests, and they are distributed over 300 parallel builds. So it happens like in really distributed manner, but it still takes a lot of time, more than 1 hour. So it's possible to run specific tests on your machine, but it's really impractical to run aggregator because it will be insanely slow. And it's not really possible because some tests are, for example, OS specific or hardware specific, and they are launched on specific agents. Not all our tests are always green, but we are working on this, and things becoming much better those days. Still, we have some tests that blink. They're mostly successful, but due to some data race or reliance on external service or whatever, they may fail sporadically, and we have to investigate this. But as I said, it becomes better. Here is how common tests look like, and it's only test data. The test itself is very short. It says like create, for example, Java 11 project, open this Java file, enable inspection like constant values, and it should produce 2 warnings in designated places and no warnings in any other places. So we simply assert that this is only a part of the whole dependency graph of this aggregator build, and you can see that some tests are grouped by semantics. For example, there are debugger tests or Android tests or whatever, but if some group becomes very big, like JavaScript tests, they are split to separate buckets. It's easy to say that this group is big, just split it to 4 agents and run them in parallel, and if we need to add one more bucket, it also can be done easily. So I said that everybody works in master branch, but everybody needs to run this aggregator before pushing, and running aggregator locally is impractical. So the solution for this is our internal safe push plugin. It integrates seamlessly with our push dialog. So you just have, instead of push, another button called test and push. And under the hood, it creates a new branch, commits your commit there, then pushes this branch to TeamCity and instructs it to run your changes, run aggregator against your changes, and everything. If successful, then it rebases it on master branch. So you don't need any manual branch management. You don't even know how this branch is named. And if everything is successful, you will just get a notification when aggregator successfully passes. So, and if flaky test happens, it retries to see if it's like flaky test or really a new regression. So it's pretty convenient, and thanks to this, we don't have many regressions. We also have cherry pick robot, which integrated with space, and it's useful if you need to put something from master to the stable branch. So you cannot commit directly to stable branch. You first need to commit to master, then review it there, test it there, and only after that you can use this cherry pick robot to rebase or cherry pick this particular commit to the branch. And it's really convenient. If everything is done, you just need to press one button. You can do it even on mobile phone. You don't need IDE for this. It automatically runs aggregator in that particular branch, so you don't have unexpected regression. And if you need to cherry pick something to release branch, which is even more stable, you need explicit approval from technical lead and QA engineer. So you need to convince people that your change is really important to put it to release. This is the UI of Cherry Pick Robot. It's, as I said, it's very easy to use. So it's possible to build a release package like DMG file or dep package for Linux or like executable file for Windows locally on your machine. But we don't use Maven or Gradle. Instead, we use our own homegrown tool. It was written on Gantt, on Groovy, but now it's mostly converted to Kotlin, so you can just run it locally. If you really need an executable package, you want to test your IDE like completely fairly, like users will see it, it's possible to do without asking CI server. Let's see what happens on our code review. For code review, we perform reviews mostly post-commit. Some people do it in pre-commit way in feature branches, but most people do it in post-commit. So we first commit to master and only after that create review. This also increases development pace as you don't need to depend on reviewer. Reviewer could be like on vacation or very busy to review your changes, but you still can move on. Or even if you notice some problems, you can fix them and attach new commits to review. It will work as well. But if you want to put changes to stable branches, then review is required and it should be done before you move your commit to stable branch. We used for review previously AppSource, which was our project, our product. Now it's discontinued, and now we are using Space. It has some nice features like automatic reviewer suggestion based on previous commit history. And there is also IntelliJ IDEA plugin. So some people review using web interface, other people review right in the IDE, and you can see how it looks. Well, it's kind of what you would expect from code review tool. There is a tree of changes, diff view, and you can add any comments, you can accept or reject, request more changes and whatever. And the same review is opened in IntelliJ IDEA plugin. You can also see all changes right in your IDE, and you can use your normal diff editor, use all navigation features, everything just works there, so it's really convenient. For issue tracking, we are using mostly utrack, which is also our product. Space also allows issue tracking, but we are using utrack mostly before. Utrack was created much before Space, and we used it for a long time. Now we have more than 500,000 of issues for all IDEs. It includes resolved issues, and well, most of them are actually resolved, but still we have really many unresolved issues, but it's normal, and it's because our issue tracker is public. So anybody of you can go there, create an account, and complain that our IDE doesn't work as you would expect. We have a small amount of non-public issues, for example, some security issues or licensing issues, or some people submit non-open code in the issue description to describe some problem, and we have to hide such issues. But still, you can monitor most of the work that we are doing just looking at our issues. And our support team uses Zendesk, and it integrates with Utrecht and also with other sources of feedback. So support team triage or incoming requests and assign and so on. And you can usually use not only Utrecht, but your favorite channel. For example, if you prefer complaining on Twitter, like my IntelliJ IDEA doesn't work, and provide some details, then your tweet will appear in Zendesk integration if you mention our products, and our support engineers will see it, and if it's necessary, they will create your track issue for you. We are actively using some workflows. There is like JavaScript API, and you can describe some behavior in your track. For example, if you are a new user and you are creating your very first issue, then there will be automated friendly reply, like describing the processes and speaking like what could you expect from this, or if we need additional information from the user, we can ask a question and set wait for reply status. Then if user doesn't reply for a few weeks, an automated ping, like gentle reminder, will be posted by bot. So all of this is done using workflows. There is another tool called Exception Analyzer, and we are also using it. The thing is that IDE may produce many internal errors, and if you are internal user or user of early access program, you may see red exclamation sign in the top bottom corner of your IDE, and if you click there is a button like report to JetBrains. So it's done by Exception Analyzer, and all of those reports are gathered there. There are much more reports than issues in Utrecht. I guess you have more than 10 millions of individual reports, probably even 20 millions. I don't remember actually. And they include IDE exceptions, freezes when your IDE becomes unresponsive, out-of-memory errors, and even JVM crashes. And it's very important to cluster issues, like to find if some issues are actually the same and other issues are different. It's far from trivial. You cannot just match stack traces because stack traces could be different, but the issue is still the same. And we using ML there, and it works pretty well. And another problem is to assign issue to a proper person. So the same ML model was trained on previous assignees, and it has access to Git history, so it can match stack traces to the Git history and find the best responsible person. It also works pretty well. And we have IDE plugin for internal use to manage and fix the problems. Well, this is how it looks, and you can see that a lot of problems assigned to me. Sorry, we don't fix all of them. Well, some happen not very often, and it probably doesn't worth spending too much time on them. But we fix many really important problems thanks to those reports. And you can see in the bottom part the stack trace of the report, which is actually matched to Git history. So every line says who changes this line the last. And this Git history is actually adapted to the version of IntelliJ IDEA from which we have a report. So we match version to the commit and build Git history for that particular commit. This works really like magic. And the last tool we are using is static code analysis. We develop IDEs, and our IDEs have many static analysis rules called inspections, and we are naturally use many of them. We have shared inspection profile, which is committed to Git, so everybody has the same inspection settings. This is very important because some inspections contradict to each other, and like you may fix something and you will introduce warning for another person, and another person will fix and you will get the code back that doesn't work. So instead we have one common profile, and we sometimes tune it, like enable or disable some inspections. But what's more important, we have quite many custom inspections. We have structural search inspection feature for project-specific code patterns. So you can define patterns for your own API, and it's really useful because we have many APIs internally, and it's hard to know everything, especially if you're a new employee. But these structural search inspections really help you. They will highlight your code and saying, oh no, you are calling those methods in wrong order or doing something which you should not do, and here is how to fix this. Sometimes even automatic quick fix can be applied. We have almost no inspections for naming or formatting. We rely on common sense of our developers, and we don't care too much. For example, if you have two blank lines instead of one blank line, well, it doesn't make your code invalid. It doesn't introduce bug. So we don't care much about this. And inspections are run locally right in your editor. Also, they are run on commit for all the changed files and on TeamCity. But on TeamCity, almost nobody looks there because we have like tens of thousands of warnings, so it's not very useful. Here you can see how structural search inspections look like. As you can see in the right bottom part, there are some templates defined in some template language, which is quite easy to understand, and there are some online tutorials, you can find them. So if you have such kind of code, and for example, var2 is instance of some type, then we should suggest replacement to something else and provide some kind of warning. And to a little bit enforce fixing of problems that reported by static analysis, we have zero tolerance inspections. It's a subset of inspections that have no or almost no warnings in the whole monorepo. And there is a special build on TeamCity run by our static analysis engine called Codana. And as you can see, currently we have 36 problems. So usually we have at most several dozens. You can assign investigations to individual problems, like saying that you, some particular person should fix some particular problem. So this actually works. So let's summarize. First important thing is that we are using JetBrains products inside JetBrains to develop another JetBrains products. And this is very useful not only for us, but also for that product. Like if we use UTrack, we report many issues for UTrack if we don't like something in UTrack, and UTrack team is very grateful and UTrack becomes better. This is what we call dogfooding. We are eating our own food. So we are using many shared settings in IntelliJ IDEA. Some people prefer not to commit IDE specific settings, but we don't agree with this because some settings really help to make development smooth. We have shared inspection profiles, shared run configuration, and so on. We use JetBrains Space, TeamCity, UTrack, and Toolbox Enterprise. But we also have several internal tools which are not our products, namely JPS Cache, Safe Push Plugin, Cherry, Big Robot, Exception Analyzer. And what you can do after my talk. If you are working in large company, have more than 100 of developers, you can try out Toolbox Enterprise. Just Google it, and there was an URL. You can check whether shared indexes are already working for you and configure it and see if your indexing problems become less relevant to you. You can actually save time. And I really encourage you to try structural search inspections because it's really great and helpful feature. So that's all. Thank you very much for listening. Unfortunately, we don't have time for questions right now, but I'm here for the whole evening, so you can catch me and ask something, or you can write me email or follow me on Twitter. And if you consider working with us, you can visit jetbrains.com/careers. Thank you.